All right, we are here, Algebra 2, learning target number 9, logarithms, to walk through practice quiz number 2. So, golden standard 9.1, solve for x in the logarithmic equation below. This is all about understanding how do we evaluate logarithms. What do they look like? So, again, a logarithm, the way we look at this is logarithm base 6 of x equals 2. Another way to write that is 6 to the second power equals x. Wait a second, that seems a lot easier. Let's write it like that. So we're going to take our base of 6 to the second power equals x. 6 to what power equals x? 6 to the second power equals x. Well, what is 6 to the second power? 6 squared? That's 36. Great. All right, let's do the next one. Log base 81 of 9 equals x. 81 to what power equals 9? 81 to what power equals 9? Now, here's what you got to recognize. What's the connection between 81 and 9? Well, 9 is the square root of 81. So how do we write the square root as an exponent? Turns out the square root is the same as 1/2. So 81 to the 1/2 power equals 9. The square root of 81, which is the 1/2 power, equals 9. 81 to the 1/2 power equals 9. Next one, we have log base x of 64 equals 3. So this means x to the third power equals 64. You might know this off the top of your head. If you don't, you can take the cube root of both sides. Cube root of 64 to find that x will equal 4. Okay, that's golden standard 9.1. Let's move on to 9.2. Properties of logarithms, expanding and condensing. Condense means pull it together into a single logarithm, okay? So I look through, I see log base 10 of 3 plus log base 10 of x minus 1/2 log base 10 of 16. I want to deal with this 1/2 first. I'm going to use the power property. I'm going to rewrite the other ones as the same as they were. But I'm going to take that 1/2 and I'm going to apply it right there. The power property tells me that log base of my argument to a power, that power can come out in front and get multiplied. So let's see here. Let's rewrite this. Log base 3 plus log base x. What is 16 to the 1/2 power? We just learned the 1/2 power. We remember this is the same as a square root. The square root of 16 is 4. Okay, let's start condensing. When I see a plus sign like that, that means those two get multiplied. So log base 10 of 3 plus log base 10 of x simplifies to log base 10 of 3 times x minus log of 4. Now these two, when I see a subtraction sign, I know that we are doing division inside. So that is my final answer right there. Notice it's just one logarithm. 3 times x divided by 4. All right, let's go expand. This is the other direction. This is going to be the other direction. First step, I'm going to use the power property. I see that 5 out as a power. So I'm going to bring that 5 out in front and rewrite it as 5 times the logarithm of 2 times x divided by 3. Well, let's start splitting this up. What's going on here? I'm going to undo the division first. I'm going to take that 5 out in front and say I've got log of 2x. I see it's divided by 3, which means division becomes subtraction when we split our logs up. So instead of 2x divided by 3, it's log of 2x minus log of 3. Are we done? Not yet. I see this 2 times x right here. Let's split that one up. So 2 times x becomes the log of 2 plus the log of x. And then we still got that minus log of 3. And there we go. It's fully expanded. There is nothing else we can do. That is standard 9.2. All right, let's move on to 9.3, graphing. So what do we see first? We see that the base of our log, this is the most important to check first, base is 1/3. Okay, with 1/3, it looks a little bit funky, maybe not like all of the parent graphs that we're used to, but the same rules apply. First, where's your asymptote? Well, it's x minus h. There's no h here, so that means our asymptote must be right here at x equals 0. There's our asymptote. Okay. Now let's think about our locator points. We have 2 locator points. We have 1, 0. our two locator points are at 1, 0, and at our base, comma, a value. So our base is 1/3, our a value is 1. So where are those 2 points? Did they move? No, there's no h or k value here. No h or k. So therefore, my locator points are at 1, 0, and 1/3, 1. I'm going to estimate it to be right about there. The next point that's actually going to be here, if you think about it, is 3, -1. How do I know that point? Well, 1/3 to what power equals 3? Flip the fraction. 1/3, flip it, becomes 3/1. That's the -1 power when you flip the fraction. So to graph this, I'm not going to cross my asymptote. I'm going to go through those 3 points and go out that way. There's my graph of log base 1/3 of x. All right. Now my next one here, same base, but this time I've got an h and I've got a k. So what does the +2 mean? That means I'm going to go 2 to the left. The -3 means I'm going to go 3 units down. So then my 2 locator points become what? 2 to the left means 1 goes to -1. 3 down, 0 becomes -3. Okay. With my 1/3, 1, 2 to the left from 1/3 is -5/3. All right. And then 1 minus 3 is -2. So if I plot those 2 points, I've got, first, actually, I should have started, you know where I should have started? I should have started with my asymptote. Now here, h is -2 because it's x minus -2, which makes it a plus. So I should draw in my asymptote first, right there. First step, draw my asymptote. X equals -2. So my 2 points, -1, -3 is right there. -5/3, -2 is right about there. And if I were to move this point, 3, -1 over, that would be at what? 1, -4? Right around there. So let's draw in our graph. And it kind of turns like that and goes like that. And there we go. There's our graph. Okay, standard 9.3, good to go. Let's go on to 8.4, solving with logarithms. Now, before we jump right in and start messing around with stuff, look carefully at your equation. What do you notice? I see log base 6 of 5x minus 4 equals log base 6 of x plus 3. What do you notice? I notice that the logs have the same base. We have the same base. If the logs have the same base, what do you think must be true about the arguments? They must be equal. Therefore, the arguments are equal. So what does that mean? That must mean 5x minus 4 equals x plus 3. Because if it's the same base, then they're equal, then this part must also be the same. Whatever we're taking the logarithm of must also be the same. Well, let's just solve this real quick. Just a linear equation here. So 5x equals x plus 7. Subtract x from both sides. You get 4x equals 7. Divide by 4. X equals 7 divided by 4. Okay, there we go. Now, let's look at the exponential. First step we want to do, we want to get the exponential term isolated. I want to isolate this 3 to the x minus 2 power. So I got to get rid of everything else first. So first step, I'm going to subtract 7 from both sides. So I'm going to get 28 equals 4 times 3 to the x minus 2 power. I'm going to undo that multiplying by 4 by dividing by 4 to get 7 equals 3 to the x minus 2 power. Now, there are 2 ways we can do this. 2 ways. All right? 2 ways we can do this. The first way, which is less helpful, I'm going to show you the less helpful way first, is we just rewrite this as a logarithm. So log, what's our base? It's 3. 3 to what power equals 7. So we could write it like that. Then, to get x by itself, add 2 to both sides. Now be careful here. This 7 is by itself. We're not adding 2 to the logarithm. It's outside the logarithm. So there's one expression to solve for x. Now, this one's not very helpful. It's not really going to get us anywhere because a lot of our calculators don't have log base 3. So not that helpful. What's another way to do this? Again, these are two paths to the same place. What if we took the log base 10 of both sides? So log of 7 equals log of 3 to the x minus 2 power. Now, what have we learned here? Based on the power property, this x minus 2 can come out in front. X minus 2 times the log of 3. Well, now, okay, the x is no longer an exponent. Let's start to get it by itself. Divide both sides by the log of 3. So I have log of 7 divided by the log of 3 equals x minus 2. Get x by itself, add 2 to both sides. And I have the log of 7 over the log of 3, again, by itself, plus 2 equals x. Notice here between the two of these, between the two answers. Whoops, sorry, I ran out of room there a little bit at the end. Notice this and this. The plus 2 is the same. Log base 3 of 7 is the same as log base 10 of 7 over log base 10 of 3. This one we can actually put in our calculators to find an approximate value. This is the more helpful way to do it with most of our calculators. If you have a calculator that does this, great. On your quiz, you're not going to have a calculator though. So our goal is to leave our answer in log form. Finishing here is where we want to be. You're not going to have a calculator to go through and actually see what these equal to get a decimal approximation. Leave it like this. All right, that's our quiz. Good luck.